Hello friends, today I will solve a LeetCode medium problem on strings. So the problem says, given a string s which can contain any number of star characters, our task is to remove all the star characters. So for each star character, what we need to do? We need to find the smallest non-star character to its left, and there may be multiple several smallest characters, so we can delete any of them, and we need to do it for all the stars that are present in the string. And at the end, we need to return the lexicographically smallest string after removing all the star characters. So let's discuss this problem with an example. So I will consider the first example. So I have taken the first example, which is a string containing 5 characters, and there is only one star character. So before the star character, we have the string A. So we need to remove the smallest non-star character. So in this case, the smallest non-char characters is A. But there are three A's. So we can remove any of the A, but our goal is the resulting string should be lexicographically smallest string. So in this case, let's say we'll take all the scenarios. If I remove the first A, the resulting string will be A. If I remove the second A, the resulting string would be A. If I remove the third A, the answer would be A. So we can see we need to remove the last occurrence of A. So in this case, this string AAB is the lexicographically smallest string. So let's discuss the brute force approach. So what I need to do for each star character, we need to find smallest non-star character on its left. And if there are multiple occurrences, and find the rightmost character or rightmost occurrence. So now I'll go through the approach on how to solve this problem. So first I'm converting the string to one character array. Then I'm looping through each character of the string. So this is the first for loop. So for each character, whenever I find a star, then I need to find a non-star character on its left, which we need to remove. So after processing one character, which is a star character, I assign pound character to that index. Similarly, I assign the pound character to the non-star character index, which we remove. So for each character at index I will run a loop from 0 to I minus 1, an inner loop. So here is the inner loop. I'm declaring an variable j. Then I'm looping through the array and I'm checking if there are any pound characters. We need to ignore that. So after processing all the pound characters at the beginning, it means we found a character which is a non-star non-pound character. So assign that character to a variable called smallest char, and I store that index in smallest char index variable. Then I go through the remaining characters. If I find any non-star character which is smaller than the existing character, I update those two variables, and at the end I update the star character to pound, and I also update the non-star character which needs to be removed for this star character, and I assign that index with a pound. At the end I have a string builder. I go through the array and I append all the non-star or non-pound characters to the string builder variable, and at the end I return the result as a string. So let's take the first example, A star. So index 0, 1, 2, 3, 4. So the first star character is at index 4. So I'll run an inner loop from so I equal to 4. So I'll start with j equal to 0. So at j equal to 0, so this while loop will not run because the starting character is not a pound. So I'll assign character a to the smallest char and index 0 to smallest char index. Now I'll increment the j to 1 and I'll go through the for loop. You can see I'll go to the second character, and this is also a character A, which is less than the smallest char A. So I'll reassign the char A to the smallest char. Then I'll update the smallest char index to 1. Then I'll go increment j, go to index 2. At index 2, I'll see its character B, which is less than the existing smallest char A. So I will not do anything. Then I'll go to next index A, and I can see the character at index 3 is less than or equal to the smallest character A. So I'll basically overwrite with the character A, and I'll update the smallest char index to 3. At the end, I'll assign pound value to the smallest char index, that is index 3. So it will be assigned pound value so that it will be not processed like later. And similarly, I'll assign the star to a pound value. So at the end, the string builder, we can see whenever we go through the array, we can see the non-pound characters are only A, B. So this will be the result. For example, let's say take another example. Let's say D, F, star, star, 0, 1, 2, 3. So the first star character is at index 2. So I'll run a for loop, and I can see smallest char will be D, and smallest char index will be 0 at j equal to 0. Then at j equal to 1, I can see f is not less than equal to d. So I will not update these two variables. Now I will update the smallest char index to pound, and I'll update the index I, that is star characters index, to pound sign. So this is for I equal to 2. Then we have another star character for I equal to 3. So in this case, first I'll start with j equal to 0. Then I can see at index 0 we have pound sign. So I'll go inside this while loop. So then j will go to 1. We can see at index 1 we have a non-star non-pound character. So I'll update the variable smallest char to f. Similarly, index will be 1. And I'll go to index 2, and it's a pound character, so there will be no change. And now j is equals to I, so I'll stop. And at the end, I'll update the smallest char index with a pound, and I'll update the index I with a pound. I can see at the end all the characters are pound. So in this step, the string builder will be empty. So the result will be an empty string. So let's go through the time complexity. So we can say for each star character, we are running an inner loop. So at the worst case, let's say all the characters are star characters. In this case, we'll be going through the inner loop for each index. So at the worst case, so the time complexity will be, so it will be 1 plus 2 plus 3 plus n minus 1. So it will be n into n minus 1 by 2. Or you can say we go of n square. Similarly, the space will be, as we are only converting the string to an character array, and we are using a string builder, which is at the worst case. So let's say if there are no star characters, the string builder will contain all the characters, and we are using two extra variables. So we can say the space complexity will be we go of n. So now let's discuss approach 2, which is an optimization over approach 1. So we can say what we are doing for each star character, we are finding a non-star character on its left, which is the smallest or lexicographically smallest character. So what we can do in this case, we can maintain a count array which counts the occurrence of each character. So something like an array of size 26. So let's discuss this approach with the example A, B, A star. And I have declared a count array. So for simplicity, I am taking the only two indexes 0 and 1 because we have only characters A and B. So the outer loop remains same. So while processing each character, so if it is a non-star character, I'll increment the count array index. So I'll increment the index 0 to 1. So whenever I'll process index 1, I'll increment to 2. So when I'll be at index 2, I'll increment the b's occurrence by 1. Similarly at index 3, I'll increment the count to 3. So you can see we have A's count as 3, B's count as 1. Now at index 4, I have a star character. So what I need to do, I'll go through the count array. So I'll start from index 0 and I can see the count is non-zero. So I can say the minimum character on the left is A. So I just need to find out the rightmost index of A and I'll then update both indexes. Then we can update both the indexes as found so that we can skip those indexes in the result. Then at the end, I need to also decrement the count because I'm processing occurrence of A. So as I'm updating this A to pound, so I'll decrease the count of A. So now the count of A will be 2. Similarly, let's say there is another star at the end. So in this case, the A's count is right now 2. So I need to find the occurrence of A on the left. So that will be this index. Then I'll update this index to pound. Then I'll update the star to pound. Then I'll decrement the count of A by 1. So let's consider another example. df star star. So the first occurrence of star is at index 2. So I'll start the outer loop. The first index is not a star character, so I will increment its count. So the D will be at index 0, 1, 2, 3. So I'll increment it to 1. So I have only taken 6 characters because to accommodate till F, like I haven't written down all the 26 indexes here. Similarly, I'll go to next index. So F will be at index 5. So to find out the index of any character, what I can do, I'll do array of I minus character A. For F, I'll increment the index 5 to 1. So whenever I'll go to this star character, I'll loop through the array. I'll check the first character having count greater than 0 is at index 3. So that is character D. So what I need to do, I'll decrement the count of character D by 1. So it will be 0. So I'll traverse from like this index and I'll find the first occurrence of D. So it will be at index 0. So I'll update the index 0 to pound and I'll update this star to pound. Now new string will be, now I is at this index. So I'll go through this count array. I'll see the first non-zero count is at index F. So I'll find the occurrence of index F on its left and I can see the F is at index 1. So I'll decrease the count of F by 1. So now the count will be 0 and I'll update the F index of F with pound. Similarly, I'll update the star with pound. Now the resulting string will be pound, pound, pound and pound. And there are no non-star, non-pound character. So the result will be at the end an empty string. So if I go through the time complexity, so the first time remains same, finding out the star character. In the inner loop, first I need to go through the count array to find the character which is non-zero. Then I'll run a loop from index. So j will be index I minus 1 till 0. And whenever I find that character, I'll break from the inner loop and then I'll update the count and I'll update those two indexes to pound. So the worst case, the time complexity remains same. That will be order of n square and space will be. So here I'm using extra 26 spaces for count array, but so it's a constant. So the space complexity remains same. That will be order of n. Now let's look at approach 3. In this case, I'll maintain a array of lists. So something like list of integer index array, that will be new list of 26. So I'm maintaining an array of lists. So let's consider the first example. So what I need to do, so whenever I see a non-star character, I will store that index into the array of list. So for simplicity, I'm considering only two indexes 0 and 1 because we have only characters A and B. So what I will do, so whenever at this index when I is at 0, I will push the index 0 to this index array. So for character A, it will correspond to the index 0 in index array. So I'll store the index of A in this index array. So it will be 0. Then I'll increment I to next index. Now it will be 1. So I'll store this index in the index array. Then I'll go to index B. So I'll store the index of B. Now in the index will be 2. Now I'll increment I. Now I'll store the index 3. Now at index 4, it's a star character. So I'll go through the index array. So I'll check for the first index whose size is greater than 0. So in this case, at index 0 of index array, I can see the size is greater than 0. So it means there is an occurrence of character A. So and to get the rightmost occurrence of character A, if you would have seen in the previous approaches, we used to run a for loop. Now we have the last occurrence in this list. So what we can do, we'll pop out the index 3 from the list. We'll mark the index 3 as found and I'll go to the next star and I'll update the star with found. Similarly, let's say we have another star at index 5. So what I need to do, I'll go through the index array and I can see for index 0 or character A, the length is greater than 0. We can say that there are other occurrences of character A, and to find the rightmost index, I can take the at the end of the list element, which we can get it in order of 1. So I'll remove that element and I'll update that index to pound and I'll update the star index to pound. We can see at the end there will be only two characters A and B, which are non-star non-pound characters. So let's consider another example. Let's say we have string df star star. So it is 0 1 2 3. So I'll consider index array. So only I have written down the 6 characters because we are using till f, so I haven't drawn all the 26 spaces. So initially all the sizes are empty, so I'll process the string. So I equal to 0. At index 3, I'll store the index of character D, that is 0. I'll go to next index, I'll store the index of f, that is 1. Then I'll go to next character, which is in star. So what I need to do, I'll go through the index array, I'll check for the index whose size is greater than 0. So this corresponds to index 0. So I'll update index 0 to pound. I'll remove index 0 from the end of the list and I will update this index 2, that is star index, with pound. Similarly, I'll go to next index. I'll scan through the index array. I'll check for this index the size is greater than 0. So I will mark index 1 as pound. Similarly, I'll mark index 3 as pound. And I'll remove the index 1 from the index array. So you can see at the end the resulting string will be pound 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 pound, as there are no non-star characters, so the result will be empty string. So in this case, what we are doing, we are optimizing the inner loop to get the last occurrence of the smallest character in order of one time or constant time. So optimized inner loop, we go of n to we go of 1. So the time complexity will be big O of n, because the inner loop is optimized because we are doing some constant operation. So for each star we are going through the index array, so that will be at the worst case 26 characters, so it's a constant. And after finding the index which size is greater than 0, we are removing the last character and we are updating the last character with a pound. So these are constant operation, constant number of operations. So you can say we optimize the inner loop from order of n to order of 1. So space will be, so in this case we are using an array of lists. In the array of list we are storing index of non-star characters. So at the worst case, let's say all the characters are non-star, so we'll be storing all the indexes. So in that case we need order of n space. So we can say the time is big O of n and the space is big O of n. So now let's see the code. So here I'm converting the string to an character array. Then I'm declaring the index or index array, which is an array of list, and the array size is of size 26 because we have only lowercase English characters. And I'm assigning all the 26 to our empty array list. Then I'm going through each character of the array. So if the character is a star character, then I'm going through the index array or index, and I'm finding out the index for which the size is non-zero. Basically, like the character which have a occurrence on left of it. So if the size is not zero, so I'm taking the last index of that character, then I'm removing that index from the list. I'm updating that index in the list to pound, and I'm breaking out of the loop. And at the end, I'm updating the index of the star character, that is character I, to pound. And if the character is not a star character, I am adding the index I to the list at index array of I minus character A. So I'm first finding out the index of that character in the index array, then I'm adding the index of that character to the list. Then I'm declaring a string builder, and I'm going through each character of the array. If the character is not a pound, then it's a valid non-star character which is remaining after processing all the star characters, and I append all those characters to the string builder, and at the end I'm returning the string builder as a string. So as I have discussed, so the time complexity will be big O of n, and the space complexity will be also big O of n. Now I'll run through the basic test cases. Now I will submit it, and it's working as expected. Thank you.